Okay, class, this is our last lecture for the year here. This is going to be our review, going over stuff for the final exam. Final exam is going to be available online, up on pause, and it's only available on pause. I'm not mailing you a copy of this. But it's up online either May 1st through the 7th. You can take it at any time during that time frame. You've got 2 hours to take it, and it will cut you off after 2 hours. It's the exact same test that I give regularly all the time, where you normally only have the 2-hour window anyway to take it. Most folks finish it within 45 minutes to an hour, so you'll have plenty of time to take it. Of course, since you're taking it home, yes, you will be able to have references, textbook, notes, study guide, the 2 previous tests available to you to look at. That's fine, I don't care, all right? But just keep in mind that you will not have time to look up every single question, okay? So you need to study for this just like you were studying for it in class when it was not an open note book test, all right? And just use those references for there's 1 or 2 that you're drawing a blank on or totally confused on or something like this, okay? So basically what the review is going to be, of course, what you need to do, final exam is just like all my other tests, okay? Except there's 100 questions this time, and it is incorporating information from the very first of the semester all the way to the end. Now, the good news is that even this last test where we get into climate and severe weather and everything, we're still using almost all of the same vocabulary, same concepts that we started way back at the beginning of the semester. So none of this is going to be, oh crap, I hadn't listened to this or thought about this in 3 months or something like this. Probably the only thing you'll need to refresh are some of the Earth-Sun relationships, like aphelion, perihelion, and things like this. But again, same exact style questions. It's not the exact questions that were on tests 1, 2, and 3, but it's the same vocabulary. It's the same concepts and things like this. So use your study guides that are there. That's what I've always said. The review for the final is just taking study guides 1, 2, and 3 and staple them together, and there you have it. What I'm going to do for today is mainly I'm going to go over all the tests. Now, granted, you've got test 2 and test 3. You've seen the correct answers, but I'm going to go through those answers again, explaining the answers, telling you what you should be thinking in your head, and hopefully this will help you in taking the final exam and how you should approach the questions, what you should be thinking about in your questions to figure them out, all right? Now, a lot of this, as you've probably noticed, probably 50%, if not more, is strictly knowing your vocabulary words. And you guys have got to do that on your own, all right? You've got to learn the vocabulary words. First step in learning the vocabulary words is, what is that term associated with? Is it a insulation term? Is it a Earth and space with orbit and revolution type of term? Is it something to do with air pressure? Is it something to do with humidity? So learning the big category is going to be your first step. And then, of course, learning the actual definition will be the second. I suggest flashcards is often the best way to do that. Mix up those flashcards so you're not always looking in the same order. And then, of course, the rest is just the basic concepts. One thing we've learned is for almost everything, it's based off of air pressure, which is actually based off of temperature, which is often based off of the amount of insulation that you are getting, okay? And so as long as you keep that key thing in mind, remember this, I didn't rewrite it out here, but that air that is colder is going to sink, all right? If it's colder, it's going to be denser, therefore it's going to sink. That's associated with high pressure, and that means you're going to have clear skies, all right? Pretty much like today, which was, this was Sunday, whatever, 25th, 26th, whatever Sunday is. Like you, I've lost track of all these days. But a gorgeous, gorgeous day out. A little cooler temps. We had a little cold front that came through, all right? So we had cooler air today. I don't think I'm looking out my window, I haven't seen hardly a cloud at all out there, okay? Air that's warmer, all right, means it's less dense, so it's going to float. It's going to rise. If air is rising, we're going to be able to get adiabatic cooling going on, which means if we've got, enough moisture available, we can get clouds. And if, again, still enough moisture and enough lifting going on, we could get rain out of that. So low pressure is going to be slightly warmer temps and is, possibility of rain or cloudy skies. So keep that key element going in because pretty much everything is based off of that. So anyway, all right, going over test 3, and I've got an itchy nose here, so excuse me. All right, you can follow along with your copy. I'm just gonna, kind of go through it and again, give you the explanations for the answers. First one was tornadoes are common on most continents. That's false. We know that tornadoes normally occur in mesothermal thunderstorms, of which we get the most here in the U.S. because of our lovely battlefield zone going on here. Okay, tornadoes are very common throughout the central part of the U.S. down into the southeast where we are. All right, we average over 1,000 tornadoes a year. That comes with that massive cold air that comes down and meets up with the warm air that comes up, all right, and makes these extreme weather situations. The same reason that, again, we're going from hot to cold to hot to cold to hot to cold and back and forth. Now, we're the only place without the mountain ranges that run east to west and block off the cold north air from the warmer, wetter south air. Every place else, now, there are tornadoes that do occur. Some of those videos that I gave you links to occur over here in Siberia, all right? And they occasionally get them in Europe or other parts of the world. Occasionally they even get them, in the Pacific Northwest or even over in the northeast of the U.S. But it's rare there. It is very rare there. But for the central U.S. and the southeast U.S., yay, lucky us. It's just totally common. And yeah, that's where they most occur. So they're not common on most continents, just us. Yay. All right. Tornadoes spin as a result of the Coriolis force. That's false. In order to be affected by the Coriolis effect or the Coriolis force, things have got to be quite large. All right. And even the largest tornadoes are maybe about a little over 2 miles wide. And those are really big ones. Most are nowhere near that size. And they're simply not big enough to be affected. Just like your toilet flushing is not affected by Coriolis, neither are tornadoes. They're too small, okay? Question 3, hurricanes spin as the result of the Coriolis, and that's true, all right? A hurricane is just a very large tropical low pressure center, all right? Those suckers are large. They're anywhere from 100 to 300-400 miles wide. And yes, all right, those are affected. And just like our mid-latitude cyclones are spinning as a result of the Coriolis. Same thing with hurricanes. In fact, we know that you've got to have some spinning, all right, the Coriolis effect in effect for a hurricane to even form in the first place. All right, which brings us to the next question, which were the following ocean regions that don't develop a hurricane or a typhoon or whatever the local name is? They're not going to occur right at the equator because even though, lovely warm water, which we got to have warm water, all right, because that's the actual key element, but you got to kind of have Coriolis to kickstart it. And we don't have any Coriolis effect at the equator. All right, so we're not going to have any form there. But we also need the warm water. The warm water is what sustains it. First, you've got to have warm water, again, to kickstart it as well. Think of it as starting a regular old pull lawnmower, all right? So the pulling action to get it spinning and going and get it started is Coriolis. along with warm water. But once it's going, all right, it can move up, and what's going to keep it going and keeping it from dying out, all right, is going to be warm water, all right? So that's why once the the hurricanes go up onto the land, they tend to die out because they still got Coriolis going on, but they don't have the warm water, all right? So where we're not going to see them form is where there's not warm water, which is going to be any of these far north regions. Once we get up in the higher latitudes, all right, same thing with down in the south as well. But, you know, the North Atlantic, the North Pacific up here, it's too cold. So even though we have Coriolis, you don't have the warm water. And you got to have both to get them started. Okay? You got to have both to get them started. So that was a combo answer. So both the northerly cold water reaches, all right, too cold for them to start. And you don't have them at the equator because you don't have the Coriolis effect going on. Okay? So it's a combination. All right, talking about thunderstorms here. Cool wind that immediately precedes a approaching thunderstorm. That is the gust front, which is basically made from the downdraft that comes down, hits the ground, and gets deflected and blows towards you. All right. And that's also, it's going to be those downdrafts that just cause a lot of the regular little winds that occur in thunderstorms and stuff like this. Your choices for this question were wind shear, okay, which wind shear is, not all storms have wind shear. Wind shear is when you've got winds blowing at different speeds in different directions, okay, which that's not that. Squall line is just when you're looking on a map or on the radar and you see that course line of thunderstorms all lined up in a nice linear deal that's right in front of a cold front and pushing on through. That's a squall line. It's not a wind term at all. Derecho is some straight line winds. We didn't even talk about this, and so that's, you don't even worry about it. You're like, I don't know that. We didn't talk about that, so you can eliminate that. Okay. Let me break for just 1 second. Again, remind you that the final exam is not going to have these exact same questions. All right. So in this question, I was asking about, you know, a gust front. I might be asking about the wind shear on the final exam. You're expected to know all of these types of stuff that go on. Okay. So don't be using this as, again, to memorize that the answer to number 5 is B, or to know this exact question. You need to know what all the different words and answer choices are and things like this. All right. Hail and sleet are synonymous was false. Hail is that recycled ice balls that occur in thunderstorms, all right, versus sleet, which is just a wintertime precipitation where you've got liquid raindrops that fall through a cold layer of air and then freeze solid into a little pellet and then whack you on the head. The hail is a layered type of situation because it gets different layers of water refroze on it every time it cycles through a thunderstorm. Okay, so they're not the same thing. That's the, you know, even though they're both made of ice, they're totally formed in different manners. Most damage from hurricanes results from, that is the storm surge flooding. Yes, there are winds, all right? We're not knocking the fact that there are winds. But as far as land goes, and especially human structures, okay, we can prepare for the winds. You know what's coming. You can board up windows. You can shore up walls and things like this. But it's the storm surge, that flooding, that comes in and washes out buildings completely away from their foundations, or will bring ships washed in a mile inland and things like this. So I'm not saying that winds do not cause damage. They're just, you're going to have more damage from the storm surge. Okay, that's the key thing. Lightning occurs between clouds, within a cloud, and between a cloud and the ground. All 3 of those. All right. Hurricane's main energy source is, all right, that is the warm water. All right, that's what sustains it, as we mentioned before, the warm water. So that is why they will die down once they get onto land. Okay, because they still got Coriolis force on land, but without the warm water to cause uplift and adiabatic cooling and things like this, without that warmth as your energy source, okay, that's what it is. So you need that warm water. You need the source of the water, and that's so warm water is hurricane's main energy source. All right, during a thunderstorm, high damaging winds often originate. Your choices were updrafts, microbursts, or hail. And that's going to be microbursts, because microburst it's a downdraft. All thunderstorms have your updraft, and then you have the downdraft. All right? But sometimes those downdrafts, that's again where your typical little gust front comes from, and some of your regular little winds come from. But sometimes it's an uber downdraft that may be coming down at 60 or 100 miles an hour, crashes down, whoosh, and pushes out. It can be a wet microburst or a dry microburst. Wet just means it's coming with a torrential amount of rain. Dry means not that much rain. All right, but that's what a microburst is. Those are pretty rare. Okay, like I said, I've only experienced, what did I say, 2 of them that I'm aware of in my life that I watched. So that's a long life. We know that. So anyway, so that's what that one was. All right, to be considered a supercell, thunderstorms have to have a mesocyclone. That is that horizontally, or it starts out horizontal, got wind shear, that makes the air rotate horizontally. And then the original updraft is going to lift it up and get this rotating column of air. That's the mesocyclone. That is key to its long life, all right? So, one of your other choices was tornado, all right? Most tornadoes do form from mesocyclones, but not every mesocyclone. In fact, most mesocyclones do not have tornadoes, okay? Gust front, we know that's not the answer. And then hail is, you have hail just in regular old thunderstorms. Simple single cell thunderstorms can have hail. They're not just mesothermals, okay? All right, climate, initially based on which 2 elements of weather? That is always going to be temperature and precipitation, spelled correctly. This was question number 12, and answer A is the one with temperature and precip spelled correctly. D, you can hold it up here, all right? And D has it spelled incorrectly. So, like I said, spelling is still important even on these multiple choice types of questions. I want you to be aware of spelling. Okay? Very, very important. All right. In almost any climate, as you go poleward and inland, so as you get further away from the coast and also further away from the equator, things are going to, what happens to precipitation? It's going to decrease. All right? You're getting into colder temps. As we know, colder air cannot hold as much water vapor in it. And of course, as you get more inland, you're getting away from your large sources of water. So precipitation, as a general rule, is going to decrease. There's going to be less of it the further inland you are and the further poleward you are, because this would also apply down in the southern hemisphere as well. Okay, so you get into colder temps, the air can hold less moisture. You get further away from the coast, you have less moisture available. All right, so precip's going to go down. Our climate classification system is Köppen. All right, it's the Köppen. Genetic, of course, is just made up word. De Kuyper is actually a type of liquor. We might all be having too much of that recently. Doppler is that radar that we use for looking at rainfall and things like this. But it was, this Mr. Köppen, this German guy or whatever is his name, wherever he came from, European guy. that came up with our classification system. All right, globally, most major climates are distributed latitudinally. We know we have the warm tropical climates. Then we have the mid-latitude moderate climates, all right, with the mesothermal here in the middle, the microthermal as we're getting higher up and it's getting colder. And then, of course, we got the polar up at the very high latitudes. So that is how most of the major climate types are distributed. We can also define climate by vegetation types. All right, we know that Köppen actually uses vegetation boundaries to further delineate where you find more specific climates. We know animal life goes along with that. We do not find polar bears, for example, down in the tropics. Okay, and winds. Because we talk about monsoons and things like this, about winds coming from different directions. So all of those will help further refine those major climate classifications into those smaller subclimates and such as that. So all of those can help define climate into more specific climates. Which one of those was not a major climate classification? Your choices are highland, which is, microthermal, which is, polar, which is, and desert. And the key for the reason I did this, desert is the answer. Desert is one of the subclimates under arid. Just because we tend to forget that there are two arid subclimates. There's desert, which we all just tend to use generically for a dry climate, but there's also the steppe climate, okay, which is not quite as dry as the desert, but it's that transition. It's still a dry climate. They don't have any excess rainfall, so you don't have permanent streams, you don't have big lakes or anything like this where water stays in all year round or anything like this. So it's still an arid climate. So, all right. Question, it's never, ever, ever going to get below freezing in a tropical climate. Well, that is false. Remember, weather is right here and right now. Freaky things happen in weather. You can get some weird phenomenon where for 5 minutes on one day, 40 years ago, somewhere, here in the tropics, it dropped below freezing, all right? But it's not going to change the climate. That's the whole key, is that freaky events happen in weather, but they get basically, canceled out in the long run. Because remember, climate is about 30 years worth of information, okay? It's just averages. That's what we're looking at, is averages. But you get freaky events, those are outliers, and you don't usually take those into account at all, okay? So, again, freaky things happen. It has happened. All right, urban heat island is an example of a microclimate. Yeah, urban heat island is exactly, it's talking about cities with their vast amounts of both concrete and asphalt and, tall metal buildings and then plus people and air conditioners and cars and all this type of stuff. Excess amount of greenhouse gases and heat generating items and stuff tend to be anywhere from 5 to 15 degrees warmer than the surrounding countryside. So Memphis, the Memphis metro area, all right, we are subtropical climate, all right? However, Memphis tends to be, again, on average, a few degrees warmer than even places like, again, further out in the countryside, and even smaller cities like Dyersburg or Jackson or Moscow or, Wynne, Arkansas, or even West Memphis and things like this. So we are considered a microclimate, just like, again, the north side of your house, that's going to be cooler, or the south side of your house, that's going to get more direct sunlight and can get hotter, things like this. This is one. Even after I give you the exact same question and tell you this, folks still get it wrong. Question is, polar-like climates can be found at the equator. All right, and that is very, very true. All right, because people forget that at the equator, we have mountain ranges that are very high. Here we have the Andes in South America. We've got some volcanoes over here in Africa, all right? These have these have ice caps on the tops of the mountains due to the elevation, okay? And I'm looking in the picture, I'm realizing I've got a bright light behind me. That is just, let me see. I'm gonna have to pull my shades down for a second because that sunlight is moving on. Let me see. Is that stopping? There we go. Not as bad. Okay. So, see that sun is moving. It's in a different place than it's been in the past weeks. Coming in my west facing window, which is right here. All right. We know how that moves. All right. But anyway, so yes, polar-like climates. Again, it says polar-like. Ice cap, completely snow all year round is an ice cap. Due to elevation, you can have those, okay? Even on the equator. All right, question 21. To be a desert, temperature of a region can't drop below freezing. Well, that's false because temperature is completely irrelevant in classifying a desert, all right? In fact, many deserts get below freezing. Many deserts are both high latitude and some are even high elevation. And so they get freezing all the time, right? It has nothing to do with it being a desert. It's a lack of precip, okay? Land barriers can be the cause of a desert subclimate. Of course they can. That's what a rain shadow is. We've talked about that. All right, Mediterranean subclimate. The evening temps are usually very hot. That is false, all right? Mediterranean belongs under mesothermal. Our best examples of Mediterranean that usually we're familiar with is going to be Southern California, all right? And these are very, they have very, very dry summer times, all right? Due to the fact that the summer, they are dominated by the Pacific high pressure over here, which means no rain, which means it's very dry. Water vapor is a greenhouse gas. Lack of that means that they are not muggy, which means at night, also lack of rain means you don't have any clouds. So at nighttime, any heat that comes in escapes all out, so it gets quite cool in the evenings, all right? Talking about if you went to Disneyland and we're gonna watch the fireworks at night, you would need to bring a sweater with you because they routinely get down into the low 60s, upper 50s, even in the summertime. Even though it might have got up to 100 degrees during the day, by evening it gets quite chilly, all right? All right, subtropical subclimates have a very distinct dry season. Subtropical falls under mesothermal. Subtropical is also what Memphis is. And as you know, we do not have a distinct dry season, all right? Even though we may not get quite as much rain and storm fronts and stuff coming through in our summer months, we get plenty of convective thunderstorms, which account for quite a lot of rain and means that we have year-round rain that goes on. Microthermal climates are found on all continents but Antarctica. That is false. They are only found up here in the northern hemisphere and the upper latitudes. The reason being, in the southern hemisphere, at those same upper latitudes, there's just not enough land to fall within that, okay? So we do not have microthermal in South America. We don't have it in Africa. We do not have it in Australia, all right? So that's why that was false. Mid-South, that's us, classified specifically as which type subclimate? We are subtropical, all right? That's it, we are subtropical. Annual temperature range of marine west coasts, all right? Marine west coast. West coast, marine, water influence. We know the influence of water is going to keep things from getting too hot or from too cold, which means you're not going to have very much variation between the summertime high and the wintertime low. right? That's that whole, part of that whole marine effect, keeping the temperature range fairly low, not big, but low. Coldest place on Earth, where was that located? Okay, well, our choices were Canada, all right, which is cold up here, but we do have the big old Hudson Bay right here, water, so moderating influence. We've got Siberia, which is landlocked, big section over here, all right. We had Antarctica, chosen twice. Well, the answer is Antarctica, which is even off my map, but we know Antarctica is at South Pole, so it's getting, of course, least amount of insulation. And it's also covered by land completely, which means it's going to get colder, because we know land gets colder than water does. Plus, it's got a high elevation, all right? Most of this is over 10,000 feet elevation, so additional cold that goes on. And this was a spelling one as well. Antarctica is spelled with, there we go. All right, it's this question right here. But there is a C, it's Antarctica, not Antarctica, all right? There's a C there in the middle. Again, spelling, very important. All right. Subclimate, infamous for being cloudiest, foggiest, rainiest. That is marine West Coast. All the places that are marine West Coast. So our Pacific Northwest, that's like this. All right. UK, Ireland. In fact, most of northern, Western Europe, this area up here, even the coastal areas up here in Norway. We see it down in Chile, southern Chile, all right? And we also see it in New Zealand. All these places are famous for being cloudy all the time, drizzly all the time, foggy, you know, not a whole lot of sunshine at all, right? Not stormy, just raining all the freaking time, right? All right, tropical climates are found in the tropics on my map here. It's the dotted blue lines. So it's this fairly wide band from, you know, right around 30 degrees north, or, you know, making it easier for you, right at the line of the tropic, 23.5 north to 23.5 south. All right, so this nice wide band right there is where you're going to find your tropical climates. All right, important crop of the tropical monsoon. This is where they get tons and tons and tons of rain. About the biggest place we talked about this happening is over here in Southeast Asia. Okay, India and Southeast Asia, where they grow rice. Because remember, rice grows well in flooded fields. Okay, so that's why the rice is the huge staple in those monsoon climates, where those huge flooded fields would drown out anything like wheat and corn or something like this. All right, arid climates, all right, are found just about everywhere. Okay, they're scattered around. There's many different reasons why arid climates can form. It's not latitudinally based at all. All right, but I want to make sure you guys, I tried to make this as clear as I could, but your choices were at the equator, very, very narrow band, just literally right at the equator. All right, this big wide band that basically incorporates all of the tropics, tropical latitudes. All right, we have two mid-latitude bands, which would be up here, and then also the southern hemisphere version. All right, that's what the other choice was, and then again anywhere. Okay, so arid climates anywhere. They're scattered about due to many different reasons. We want to know which climate has the highest percent of insulation reaching the ground. The answer for that is arid, all right? That's because arid means they're not getting rain, which means you don't have the clouds, and you don't have clouds to act as a barrier for insulation coming in, all right? So you take the clouds away, and close to 90% of insulation can make it through on a yearly basis, versus the 45% we see on average for the rest of the planet, because most every place else is going to have varying level degrees of clouds that will end up blocking things. Native vegetation, which means what grows naturally in an area, is very dependent upon, well, your choices were solar flares, longitude, underlying rock structure, and then climate. And the only one we've ever really talked about and would make sense for this is going to be climate. Okay, since that's the whole topic of this test that was up here anyway. And again, we know we use the native vegetation for the boundary lines between different climates. All right, most of the Amazon basin is representative of which subclimate? Amazon is down here in South America, based on the Amazon River, all right, which is mostly in Brazil, but this is where, you know, it's close here, close to the equator. That's the tropical rainforest, the Amazon rainforest, along with the Congo rainforest, which is in the Congo River Basin over here in Africa, along with all the other rainforests that are right over here in Indonesia, Philippines, and Southeast Asia. Again, right around the equator, where they get lots of rain all year round because it's hot there. And, you know, you have, it's low pressure belt that's also found there, which means rain that comes in with that. All right, this is one that I think screws a lot of people up. Which following would not contribute to the location of the desert? As in, you know, clarifying it as in, which one is just, you know, there are multiple reasons of why a place is a desert, all right? And of your choices here, one of them is actually a symptom of being a desert. It's not, doesn't cause you to get a desert. So, first choice was subtropical high pressure cells. Well, that's going to cause an area to be a desert, all right? Because we know high pressure, air is sinking, means no clouds, no rain. Okay, so that's a reason, a cause for an area being a desert. We've got mountain barriers and continentality, which I can never say that word right. Mountain barriers, we know you can get rain shadows, which are deserts. We know in smack dab in the middle of a continent, all right, away from any source of water can lead you to being a desert. We talked about wind directions and ocean currents. We talked about the reasons down here, like the Atacama along the coast. The fact that you've got a cold water current flowing along the coast. You have warm, wet winds blowing this direction. They hit that cold water current first, condense out, squeeze all the water out, and so by the time it hits the land, the air is very dry. Okay, so that's a cause. But an area that has strong wind and sandy swells, that is a symptom of being a desert, all right? Where you have a lot of differential in heating during the day going on, which can set up strong winds. Also, many of the areas, especially with a lack of vegetation, have wide open spaces, which mean that winds can build up quite a bit in those areas as well. Having sandy soils, that's often a result of, because the strong wind will blow away any finer soils away, and you're left with the clunky sandy soils. All right, so those are just symptoms that you can sometimes find in areas that are already deserts. Okay, they didn't cause. There's plenty of places you can have sandy soils. Most of your beaches, Florida has lots of sandy soils. It's not a desert, okay? Sandy soil does not make you become a desert, okay? That transition subclimate between a desert and any other humid climate. All the others, your tropical climates, your mesothermal, your microthermal, even your polars are all humid climates because they get plenty of rain year-round, so you can have an excess amount of lakes, rivers, whatever, hanging around. But the other arid subclimate, right, that you're going to find between the drier deserts and the more humid, whatever it happens to be, that's the steppelands, where they get enough rain to have like some grasses and stuff like this. These are plants that are very well adapted to surviving long periods of drought. All right, and again, you don't have any nice lakes or anything like that in between. Okay, so you're always going to find deserts are usually bordered by steppe lands before you get into a more humid type of climate. Mediterranean climates are always found in which regions? That's simply the west coasts. That's what we talked about, the west coasts. All right, down here, down here, down here, down here. All right, and of course these areas around the Mediterranean. You know. What type of plant is more common in Mediterranean? That was the chaparral. All right. Cactus is going to, of course, be in more desert types. Needle leaf evergreens, that's your pine trees and stuff like this. We see those in we see those everywhere, basically. Tundra, well, Mediterranean's not a tundra, so tundra is its own subclimate. So it's the chaparral, which is a lot of bushes and scrubby type of stuff and things like this. All right, which climate clearly displays your 4 distinct seasons? That's your microthermal, all right? Specifically the humid continental one, where unlike ours in the mesothermal, where yes, we still have winter and summer and spring and fall, but we know we go back and forth. Our winters are fairly mild. We do not get, snow's a rarity, versus you get up into the microthermal, the humid continental, you're going to get snow. If you live in those areas, Chicago, New York, New England areas, and other places up north, you know how to drive on snow. You have snow chains, you have skis and ice skates and things like this, because it's it's going to happen. It's a guarantee, and it usually stays fairly cold all winter too, as opposed to up and down like ours are a little further south. The subclimate has the largest annual temperature range, all right? That's the subarctic, where it's got to be a mid-latitude. Excuse me. And so you can have cold winter times and warm summer times, all right? So it's the subarctic. The subclimate that has the largest daily, that means every day, all right, temperature range, are the deserts, where you get lots of insulation comes in during the daylight hours and gets absorbed and then released back out, so it gets really, really hot during the day. But due to that lack of clouds, all those heat rises up and escapes out at night, and so the temperatures can drop quite a bit as all that heat escapes out. There's no clouds to act like a blanket and contain the heat in. So it can drop easily, 70 degrees over the course of just one day because of those daily heating cycles that go on. Characteristic vegetation of subarctic, that's the boreal forests, all right? Or again, called the taiga over in Siberia area and stuff like this, all right? Grasslands can be found in both savannas and steppe lands. Chaparral is that Mediterranean area that we know about, and then tundra is tundra, all right? Subarctic is not tundra. It's a different climate. Okay, controls of highland climates. Which one was not a control? All right, so your choice was altitude. Well, altitude is elevation. So the higher up you are, the colder it's going to be. Exposure is referring to winds, all right? Are you on the leeward side or the windward side of the mountains? You're gonna, that goes on, so that's part of it. Slope aspect, which way are you facing? West-facing slopes are usually warmer than east-facing slopes. South-facing slopes are usually much warmer than north-facing slopes. Orogeny is referring to the geology behind why there is a mountain there, is the fact that it's a volcano or a fault thrust or whatever. That doesn't matter, okay? That's the one that doesn't control the climate. Why you have a mountain doesn't matter. All that matters is that you have a mountain, okay? But how it got there, no, no bearing on your climate whatsoever. All right, want to know which was an example of a savanna. All right, savanna subclimate is one of the tropical subclimates. So the answer is not going to be Memphis. All right, we're not in the tropicals. Your other choices were Serengeti National Park in Kenya, all right, which we had talked about in the Serengeti, where you've got, that's your Lion King scenario, all right, with your big wide open spaces and all your zebras and your wildebeests and your other antelopes and your giraffes and all those guys, all those big herd animals that graze on grass, all right. The Llanos of Venezuela, all right, which is here as well. All right, all of these are on the borders of the tropical rainforests, and the Llanos is just the name of the savanna here in South America. So the answer is both of those. Both the Serengeti and the Llanos are savannas. Who's an example of marine west coast? Marine west coast is a mesothermal climate. It's the one that is found on the west coast. All right. So your choices were Ireland, which are right over here. All right. Coastal. It's an island. We've got Los Angeles, California, which is down here in Southern California, which we have used innumerable times as an example of the Mediterranean type of climate, because they have the sunny, dry, and warm summers along with the cooler, wet winters. All right, so that's not it. We have Fairbanks, Alaska, which if you didn't know where it was, you would look it up. Fairbanks is right up here smack dab in the middle of Alaska. Okay, right up here. It's mid-continental and nowhere near the coast, so it's not going to be marine west coast. So the answer is strictly Ireland. It's the only one that meets the criteria. All right, and it is, again, it's part of the UK, which we said is all marine west coast. It's over here. Which is an example of the steppe subclimate. This is underneath arid climates. It's the one that gets a little bit more rain, enough to at least support lots and lots and lots of drought-resistant grasses. All right, no trees or anything like this. And your examples are Mongolia, all right, which is over here in the middle of part of the continent. We've got our Great Plains that run from the Dakotas all the way down actually into Texas, right here in the center of us. You've got the Pampas of Argentinas, which are down here. All right, again, right close to the the Patagonia Desert that's down here. All right, as well. And if you looked that up and you saw it was covered with lots and lots and lots of grasses, like a pampas grass. Some of you may actually have those grass tops as an ornamental in your yard. So all of those are steppe climates, all right, where you find lots of grazers that go on, all right. So all of those are those transition dry climates, okay. Example of a humid continental subclimate, all right, that falls under microthermal, which means, you're going to be in the northern hemisphere and you're going to be in the upper latitudes. Still mid-latitudes, but the upper mid-latitudes. And your choices were Memphis. We know it's not Memphis because we're mesothermal subtropical. So that's an easy one. And your other choices were New York, all right. We've got London, which is in England, but we know England and all of the UK is marine west coast, so that does that one out. Our other choice was the Sahara, which we know is, the biggest desert in the world. So that's not going to be humid continental, which means New York, all right? Which they get snow in the wintertime, all right? So that's the only one that would fall into place for that. And the last question, we're currently in an ice age. That is true, we are in an ice age. We're in an interglacial, slightly warmer period of the ice age, but all the ice ages come with the peaks and the valleys. The colder temps and then some slightly warmer temps and then lots of colder temps and slightly warmer. But we're still in the ice age because we still have continental glaciers on Greenland and on the Arctic or excuse me, the Antarctic continent covered by that. So the fact that we still have those make that. All right. All right. Going on, I'm going to go over test 3 as well, or that was test 3. Test 2, just real quick. So if you want to pull that one out, look at that. All right, following which is the device used to measure air pressure? That's a barometer. Isobars, lines on a map connecting areas of equal air pressure. Yes, that's exactly what they were. High pressure is associated with stormy weather. We know that's false. We know that it's low pressure that is associated with stormy weather. All right. High pressure is going to be associated with colder temps. That's why they're denser and sinking. Okay. So it's going to be cooler or colder temps. Wintertime in the northern hemisphere. All right. Land masses, wintertime. Land masses are going to cool off more rapidly than water, because we know water maintains heat. It takes it longer to heat up, but also longer to cool off. So land cools off much more quickly in the wintertime. All right. Colder air means high pressure. The water is going to stay a little bit warmer, which means low pressure. All right, and it's questions about wintertime, northern hemisphere, land masses are going to usually have what centered over them. So we said because it's colder, it's high pressure, and another name for a high pressure cell is an anticyclone. All right, so you got to put all these things together to get these questions right. But y'all, you got to know your vocabulary words of cyclone versus anticyclone. Wind blows from low towards high is false, because it's the other direction. Remember, high pressure, nobody wants to be under a lot of pressure. So you want away from high pressure. High pressure blows toward places of low pressure, okay? From high to low. High pressure cells, winds are, well, they're running away, all right? So we know they're going to diverge, and we also know high pressure is colder, so it's denser and it's sinking. Right? So winds are going to diverge and sink. A belt of low pressure, that is going to be a trough. All right? Both anticyclone and ridge are high pressure terms. Right? So that's how you know the word trough. You're like, oh, that's low pressure, and that's the term for the belt. Okay? High pressure cell is also known as an anticyclone. Okay? That's a vocabulary word there. In the northern hemisphere, Coriolis force deflects flowing objects to the right. Yes, that's it. I want you guys to know that. Okay. A very strong air current embedded within the upper air westerlies. All right, so that's the higher level of winds as opposed to the ones down by the surface. These are the ones that are higher up above. All right, but this very strong air current embedded in it. Your choices are geostrophic wind. Well, that's what all of the upper air westerlies are. They are the geostrophic wind. So that's not going to be the name of this additional current. Your other choice is a trough, which we know is just another name for a low pressure system that has nothing to do with that. We have ITCZ, which we know is the doldrums. All right, it's the pressure belt that goes on. And then your other one is the jet stream, which is the correct answer. All right. Steeper the pressure gradient, that means the more closely the isobars are located on a map showing air pressure. All right. Where you've got, hang on. So if these are isobars, all right, different air pressure. I'm making up 90 all the way to... All right, so isobars. High pressure, low pressure. Winds are going to blow this direction across, more or less. But right here, we have there's more change over a shorter distance. This is a steeper pressure gradient. And just like a ball rolling downhill, it's going to roll faster where it's steeper. So the winds are going to be faster or more intense or stronger here where the pressure gradient is steeper, right here. Okay. Looking at the diagram, wanting to know which is the leeward side. All right, the leeward side is the one that's protected from the wind. So B is going to be the windward side because B side of the mountain is being hit by the wind. It's facing the wind. And you're protected by the wind over here. It's not going to be near as windy on this side. Okay? So that's what the leeward side means. Horizontal movement of air in response to differences in air pressure, just like we saw here. That's what wind is. All right? Difference in air pressure. High pressure to low pressure. Whoosh, wind. That's what makes the air move. Running away from high pressure. Geostrophic winds. That's the name for the winds that are high up. Not the surface winds, but the upper layer of winds. All right? And so your choices were blow close to the surface. Well, no. Okay, they're not. Is that it? Are only found in the tropics. Well, that's not it. They're found everywhere. Or blow high above the Earth's surface and flow parallel to the isobars. That's true, and that's exactly what it is. And the whole reason they flow parallel to the isobars is because Coriolis, remember? Because it wants to flow this way, all right, from high to low, but Coriolis ends up deflecting it. So that actually flows this way. Even though it's, you think it would go straight, Coriolis screws up things and makes them flow parallel. Okay. Our weather is influenced most by those geostrophic upper air winds known as the upper westerlies. It's why our weather systems normally flow from the west to the east. Again, we're always looking over to Arkansas to see what is heading our way. Okay, it hits Arkansas first before it hits us. All right. Area along the equator with no wind and cloudy skies, that is the doldrums, okay, which is another word. It's a belt of low pressure that goes on. Monsoon is a very heavy rain. We know, nope, we know that's a wind term, okay. You can have wet monsoons where you have extremely heavy rains with them, but just the word monsoon is a wind term. Typical afternoon at the beach. The wind is gonna blow, all right, from the ocean to, all right, this is very boring beach right here, all right, afternoon on the beach. Water, the land's going to heat up faster during the day, so that's going to be, the air is going to be warm and rising over that. The water's going to heat up a little more slowly, so it's slightly cooler, all right? High pressure, low pressure, sinking air is high, rising air is low. The wind's going to flow from the high to the low, so from the ocean to the land, all right? Rain shadows, which occur on the leeward sides of mountains, are dry areas. Vocabulary word. Hot, dry wind rushing down a mountain. Your choices were Chinook, fern, and Santa Ana's. All of those are examples of that. Yes, the term fern is the name, the kind of the generic name that we use, but it's also the specific name that they use in the Alps. Chinook is what we call them here in the U.S., and the Santa Ana's are those specific ones that occur over in California, but they're all examples. Most major currents move in broad patterns that are circular in shape. Those are the gyres, all right? They're circular down here between the continents, all right? That's the gyre. Which is a warm current that flows along the U.S., all right? The warm current is our side. That's the Gulf Stream that flows all the way over here, all right? Crosses the Atlantic. They changed the name, even though it's still the water, becomes a North Atlantic Drift, and that's the one that's flowing over here by the UK and even up into Scandinavia and keeping these temperatures a lot more warm despite their high latitudes. All right, it's the reason these are marine west coast versus a more, microthermal climate that we have up there. The cold one we have here on us is the one coming down the coast of California. All right, the California current, that's a cold current because it originates up here. Okay. Major control over the oceans is going to be wind. That's what gets those flowing the first time that goes over. Process of gas changing to a liquid. All right, so you're going from the gas down to the liquid. All right, that is condensation. Most water on the planet is going to be found in the oceans. It is not a trick question. It's just a trick question, and that it's so obvious that you think it's a trick question, but it's not. Okay. Air that is what can hold more moisture? That's going to be warmer air. When the dew point is reached, frost may form if temperatures allow. Yes. All right. If the temperatures are below freezing, you will get sublimation instead of condensation, and that's what frost is. Do not forget about the difference between water vapors, talking about humidity, and your relative humidity versus your specific humidity. All right, you got a parcel of air at 30 degrees, contains X amount of water vapor. We make it hotter. All right, what's going to happen to relative humidity? Relative humidity is based on your capacity, and your capacity is going to change with temperature. So the warmer temperature, your capacity goes up, which means you're going to be, you're going from a 12-ounce can to a 1-liter bottle, but you've got, 10 ounces of liquid in there. That stays the same, but in your 2-liter bottle, it doesn't fill up as much. All right, so relative humidity is going to go down. Same situation, okay, but we go from a 2-liter bottle up into, I don't know, a keg, I guess, okay? We get it warmer. But this one's asking about the specific or absolute humidity. That's actually how much water we got sloshing around in there. That's not going to change, okay? That's not going to change. Water can sometimes be supercooled past the dew point and not condense. Yes, that happens, especially if you do not happen to have a condensation nuclei, okay? So that happens. Radiation fog, that's what we get here in the Mid-South, which is only going to occur on cold, clear, calm nights. Because it's going to be cold enough. It's not going to get cold enough if it's cloudy, because clouds will trap in heat. And it's also not going to happen if you've got a lot of wind going on, because that's going to stir up the heat and you're not going to get the temperature differential. Process of evaporation releases energy into the atmosphere. That's false. It's the process of condensation, the latent heat of condensation that dumps heat into the atmosphere, that fuels all of our thunderstorms and hurricanes and all those, any type of stormy weather. You got a rising parcel of air reaches the dew point. All right, condensation is going to happen because that's what happens when you reach the dew point, and the rate of cooling is going to decrease. That's because with condensation happening, you get the latent heat being added to the scenario, so you're not going to be able to cool off as fast because somebody just turned on a space heater. Parcel of air is warmer than the surrounding air. That says it is unstable and it's going to rise. All right, stable means you stay the same or sink. Unstable means you're rising. If it's rising, that means you can get adiabatic cooling, which means you can get clouds and condensation and possibly rain. Summertime in the Mid-South, we are more likely to receive which type of precipitation? Well, we're never going to get orographic in the Mid-South because we ain't got no mountains. Convectional is what is most common in the summer versus the frontal that we get through, the rest of the year. Okay, but summertime, the frontal systems are not near as active. So it's the convectional. Okay, Nimbostratus clouds are associated with long-lasting drizzle. Yes, exactly. That's what they are. Nimbostratus, so look those up. Cumulus clouds, those are your poofy little regular clouds on a normal day, are usually made of ice crystals. No, those are water droplets. It's the cirrus clouds that are super duper high up that are made of ice crystals. Stereotypical fair weather poofy clouds, those are your cumulus clouds. Which is not a form of precipitation. Your answer is dew, all right? Because dew is condensation. It doesn't fall out of a cloud, which is what my definition for our class to make the difference between these two is, okay? Snow is frozen rain. Nope, frozen rain is sleet, where you have a liquid raindrop that just freezes into a hard pellet. That is sleet. Snow is the result of sublimation. Thanks to the little pretty little crystals that falls down. Air mass, MT, stands for maritime tropical, which means it is wet and hot. And our source region for that here in the Mid-South, the wet and hot, is going to be the Gulf of Mexico down here in the tropics, subtropical areas. All right. CP air mass stands for continental polar, which means it's dry and cold. And again, ours is coming from Canada up here, which is dry and cold. That comes down and invades us. Okay, we've got today, the Sunday here that I'm talking about this was with nice cool temps out there, very little clouds, which means the air is dry. So we're, I have Canada to thank for this air that we are under the influence of right now. Boundary between two air masses, all right, it is called a front, which is right down on the ground, all right, so where, you've got your air mass right here, moving across, and right here on the ground, that is the front. However, it's a three-dimensional object, just like this eraser is, all right, so you also have the boundary that is found on this, up on the front or on the sides or on the top, all right? That's what we refer to as the slope of discontinuity. The slope is very steep. You can't get any more steeper than a 90-degree straight up vertical, all right? Versus this would be a very small, shallow slope of discontinuity right here. But both of those terms are referring to the boundary between the warmer air mass that's out here, and this is the cold air mass, right? So the front is the boundary on the ground, but the slope of discontinuity is the three-dimensional boundary that occurs on all sides. Which is the map symbol for a cold front? It's the one with the shark teeth, all right? This is a warm front. This is a stationary front. This is also a warm front. To be considered a warm front, accompanying air mass has to be at least 60 degrees. That's false. Their terms are all relative, all right? As long as the warm air is warmer than the air it's invading, all right? So if it's 30-degree air and it's 31 degrees that's coming in, it's still a warm front, okay? U.S. weather systems generally move in east to west. From the east to the west, we know that's not correct. It's from the west to the east. And then the general path that the cyclones, the mid-latitude cyclones, and then, of course, also their high-pressure anticyclones that come with them, but the path they tend to follow is the storm track, all right? It's not the polar front. That's just referring to the general boundary of the colder Canadian air with the slightly warmer air down here, right? A squall line is just the line of thunderstorms that occur in front of a front. We know the jet stream is that air current embedded up high. So again, the answer was storm track. All right. I am going to flit through test 1 very quickly here because it's dragging out a lot longer than I thought this was going to be. They don't have many of you guys watching this anymore anyway, but let me go through them just to remind you what type of stuff you need to be looking for, the vocabulary words you need to be thinking about, and the concepts. So first one was asking about the four components of the Earth system, which are atmosphere, lithosphere, hydrosphere, and biosphere. All right, atmosphere, you know. Lithosphere is referring to the rocks, the crust. Hydrosphere is all the water. Biosphere is all the living things that all work together. The Earth is not a perfect sphere. We are a oblate spheroid, kind of squashed at the top and bulging at the middle. We study models of systems, all right? From the climate models to climate change models to weather system models. And the point is, they're not perfect. Models are never perfect. All right, we're seeing a lot of modeling with the coronavirus now, and keep in mind, those models are not perfect, all right? But it's the closest thing we have to go on. We were wanting to know, make sure you know stuff about the Earth's grid system, the latitudes and the longitudes, all right? We know that lines of latitude are parallel. We know that meridians, which are also lines of longitude, converge at the poles. We know the equator cuts the Earth into two equal halves, okay? The latitude of the Tropic of Capricorn, that's the longer name, it sinks to the bottom, is 23.5 degrees south. We know time zones are based on longitude. Grid lines that measure direction east and west on the globe. So the fact that we are 90 degrees west is our longitude line, all right? Because we have the whole western hemisphere versus the eastern hemisphere. All right, so that is a longitude with that. Lines of latitude are known as meridians. Nope, they're known as parallels. Longitude lines are known as meridians. Correct grid coordinates for Memphis, Tennessee. Know these: 35 north, 90 west. Right? 35 north, northern hemisphere, and 9 degrees west in the western hemisphere. Earth is at aphelion on the sun. Aphelion means when we are the farthest away in our orbit, and that actually occurs right in the middle of, close to July 4th, all right? So, but, you need to know when perihelion occurs as well, okay? Average distance between the Earth and the sun is 930 million miles. All right, pretty big distance. As the Earth and planets move around the sun, we follow a constant path known as the plane of the ecliptic. One of the choices was the circle of illumination. We know that is simply the boundary between the light half of the Earth and the dark half of the Earth on a daily basis. Okay. The Earth's spin around its axis is rotation, right? Revolution is as we move all the way around the sun. But our spin, as we revolve, is rotation. Nearest star to Earth is our sun, also known as Sol, or Sol, as in solar panels, or solar system. That's our sun. December 21st, winter time, all right? Direct rays of the sun are going to be striking at their most southerly part, away from us, so they're the Tropic of Capricorn. September 21st equinox, direct ray of the sun, all right, is going to strike where? Well, it's the equinox, which means it's at the equator and everything's all equal. Seasons are caused by, yes, the tilt of the Earth on its axis, but also the fact that we revolve, all right? That's why we have changing seasons. If we did not revolve, there would be different seasons from from the northern hemisphere and the southern hemisphere, but they wouldn't change. They'd stay the same. So it's a combination of those two things. When is the sun directly overhead in Memphis? Well, the sun is only directly overhead, literally 90 degrees, where you would not throw a shadow at noon because it was coming straight down. That only occurs where the direct ray of the sun is hitting, which is only one latitude at a time, and that only occurs within the tropics. We never get the direct ray of the sun in Memphis because we are outside of the tropics. Therefore, it is never directly overhead in Memphis. Okay. Northern Hemisphere on May 19th. All right, that's coming up. All right, just a few weeks, you know, what, 2 weeks away, 3 weeks away here. Daylight is going to be longer than night. You already know that. We've noticed that, you know, the fact that here I am at whatever time it is, 7 o'clock or something like this, and it's still daylight outside, all right? And tomorrow, daylight's going to be even longer than before because we're heading up until the summer solstice in June. Night and day is caused by revolution. Nope, that's rotation. June 21st, that is the summer solstice, the longest day of the year for us. The sun sets due west. Nope, sun is going to be setting very far north of west on that day, right? It's only going to set due west on one of the equinox dates. In December 3rd, who's going to have the longest period of daylight? Well, it's not going to be anybody in the northern hemisphere because we have the longer night. We know what it's like in December. So it's whoever is going to be the farthest south, okay? Whoever's farthest south will have the longest period of daylight. Color of light indicates a hotter object, all right? Roy G. Biv, the reds are cooler than the blues on the other end, all right? So Roy G. Biv, red, orange, yellow, green, blue, indigo, violet, all those blue, you know, those down there are on the shorter wavelength and they are hotter. So make sure you remember that electromagnetic spectrum type of thing. Go back for that. Energy from the sun that reaches the Earth's surface, all right? It's the electromagnetic radiation. That's what that is. We call it insolation, spelled S-O-L, like sol, the sun, all right? That's like the incoming solar radiation kind of anagram that's pushed together. Layer of the atmosphere that touches the Earth's surface, the one that we walk around in, that is the troposphere, but know all your different layers. Which ones are which? Okay, that's your mesosphere, your stratosphere, and your thermosphere as well. The most abundant gas in our atmosphere is nitrogen. Even though oxygen is very important to us, it only makes up about 1/5. All right, like, what was it, 20% or something like this. Hottest temps in the atmosphere are in the thermosphere, hence the name thermosphere. Ozone's important atmospheric gas because it absorbs UV radiation, yep, and it's up there in the stratosphere. We do have ozone that forms down here close to the surface, but we don't like that because it's toxic to us. We do not like to breathe that in. It doesn't work that good. So we like it way up above us. Troposphere, again, which is ours, contains most of the ozone. Nope, it's in the stratosphere. Normally from the Earth's surface, as you increase altitude, as you get higher away from the surface, temperature is going to get colder, right? Higher your elevation, the thinner the air is. Yes, because the air is made up of molecules which are affected by gravity. They do sink down, right? So higher elevation, further away from the surface, less air molecules packed in. Process of changing from solid directly to a gas is sublimation, but no all the way, going from gas to solids and solid to gas and gas to liquid and liquid to solid, yeah, and all that. No, all those. Vertically flowing transfer of heat, this way, this is vertically, all right? That is going to be convection, all right? Because convection, advection is this way, all right? But it's where you take the heat and you run with it. Versus just passing it on down, which is conduction. We know that 95% of insolation does not reach the Earth's surface. It's only about 45% on a global basis, average. All right, we know other places, for example, like the desert areas, they tend to get more. Snow has low albedo. That is false. It has very high albedo. Albedo is your reflective quality. Earth's atmosphere is heated primarily by the direct short-wave radiation from the sun. No, all right, greenhouse gases are what warm up, and they only trap long-wave radiation, which is the heat, all right? So sunlight comes through, short-wave, right, does not warm up the air, but it, you know, gets absorbed by the ground and surfaces, and then it gets changed to long-wave heat, which is then redirected back out. And it's the greenhouse gases in the atmosphere that trap that heat, all right? And that's the reason we're warm. So the whole reason you get warm when you step into the sun is not because the air is warmer, it's because you get warmed up by the sun. Your skin gets warmed up by the sun, but the air, it does not get warmed up by the sun. Here in Memphis, the coldest temps of the year usually occur within a few days of the winter solstice. That means they would be occurring right around January 1st, and that's not true. It's usually late January, February before that happens. All right. Warmest daily temps usually occur in the late afternoon. All right. Sky is blue due to scattering, which is not a greenhouse gas. That is nitrogen. All right. Methane is. Water vapor is. CO2 is. What do these greenhouse gases absorb? That is going to be long wave radiation. All right. We know that you've got two cities at the exact same latitude. One is by the ocean, one smack dab in the middle of the continent. The one by the ocean is going to have a smaller temperature range due to the marine effect, whereas the one in the middle of the continent will have a much larger temperature range because it does not have the moderating effect of the water. All right. Air is a poor conductor of heat. Yes, it is. All right. That's why we use it as insulation to help keep us warmer or cooler or something like this. Know your temperature scales. All right. 212 Fahrenheit is boiling. 32 Fahrenheit is freezing, but also know it in Celsius as well. Okay. Which is 100 degrees boiling Celsius and 0 degrees freezing Celsius. Meteorology is the study of weather. Climatology is the study of climates. And know your ingredients and controls of weather. And know that weather and climate are not the same thing. So anyway, if you guys end up with any specific questions, confusions, shoot me an email. Okay, I will, as you know, I respond to those fairly quickly. And anyway, you will do fine. You know this, okay? We've experienced it. You know, lots of times I'll watch the weather and things like this. So, you know, just know your vocabulary. That's going to be your biggest thing. Make sure you know your vocabulary going into this test. You know, have your key concepts and stuff like that. Make sure you understand those. So, you know, you'll do fine. And anyway, that's it. Good luck. Sorry this whole semester ended up being kind of short, but I hope you learned something. If nothing else, it'll, you know, just open your eyes to some of the stuff that's going on with the weather and the climate. Hopefully you'll know enough when we, you know, we're fighting to try and combat climate change, that you will know enough what is bad science and what is the legit science that's going on. So when you vote, which you better be doing, voting is the only way that you can change things. And, you know, pay attention to the issues and what different candidates are doing, and, you know, make your decisions based on that. But again, hopefully we've opened your eyes to, you know, to the way of weather and the climate, which affects everybody all the time, regardless of what your job is. Every job is going to be relying somewhat, you know, everybody's life is dependent on weather and climate as well. So I enjoyed teaching you. Wish I could have seen you guys in person, but appreciate you guys sticking it out through this semester. And like I said, you know, you've learned something, which I know you have. You know, you've just been made aware. If you look at clouds a little more differently right now, I will be happy. All right, so have a good semester, and have a good life, and have a good summer, and I hope everybody is well and stays well, and maybe see you some other time. See you in passing. Thanks. Bye.